Welcome, everybody, to the 2022 Plant Services Compressed Air podcast series, sponsored by Kaeser Compressors. Each podcast in this 4-episode series will tackle one of the many facets of compressed air system operation and costing. I'm Tom Wilk, the Chief Editor of Plant Services, and today I'm joined by two compressed air experts from Kaeser, Neil Mehltretter and Werner Rauer, for a discussion on multi-unit controls. Neil is Technical Director for Kaeser Compressors, and he's conducted and supervised thousands of industrial compressed air studies to help plant teams achieve significant energy savings and operational improvements. Werner is the Product Manager for Oil Injected and Oil-Free Screw Compressors at Kaeser Compressors, and is an active leader in the Compressed Air and Gas Institute, where he helped develop the widely used CAGI compressor data sheets. Welcome back, guys. Thank you for being part of this finishing episode for the series.
Good morning.
Yeah, great to be here, Tom.
Yeah, I'm excited. Here we are at the end of the second series together on compressed air systems. And again, today's topic is going to be multi-unit controls. Neil, let's jump right in and start with you. What would you say are the reasons or driving factors for adding separate controls in a system with multiple compressors?
Well, typically pressure fluctuation is the primary function. You see it in the plant, trickles back to the compressor room, what's going on. In those general situations, production equipment probably isn't working well or working right. And so if you add a master controller with a single pressure signal for everything, that's going to ensure pressure stability. And so, typically what happens is you have multiple compressors. Those individual compressors are fighting each other. Maybe they're coming on together or coming on in succession. And that really does not only waste a lot of energy, but it causes premature wear and tear. And your runtime between failure is going to increase. So excess starting and stopping and idling, all of these things affect overall system performance. Other ways that, or other reasons to add a master controller or a separate control would be maybe addressing potential control gaps, or really what most people would say, the wrong compressor at the wrong time. So instead of having the 100 horsepower operate for the 400 CFM demand, you have a 500 horsepower compressor running for that same demand. So if you have a different constellation of compressed air equipment, it makes it a lot easier if you have one master orchestrating what's happening in the facility. You also have that need to balance runtime among same size compressors for scheduling service. So those are really kind of the impetuses that we see in the industry. And I think Werner probably wants to go in a little bit more detail.
Yeah, thanks, Neil. You mentioned the pressure, how important it is. So a single separate control basically also adds its own system pressure signal, usually a transducer, and that's what it's using to orchestrate all of these compressors rather than relying on these multiple individual signals and logic. So you can just go up to one device and make those changes and improvements to your system. So, okay, so here's the reality, where you have a bunch of compressors of different vintage, and you're asking yourself, how can I make them play nicely together and possibly get more information about how my system actually works all day and all week? Maybe it would be helpful to have a babysitter for my system, and that would be the one spot to tell me what energy I put into my system and how much do I get out of it, useful for my plant. Or what seems to be going on every time we have a shift change, lunch break, or for example, last Saturday afternoon when nobody was supposed to be working here and we had a low pressure system alarm. So yes, you can get all of this with one modern system controller that is able to connect all of your system components, not just compressors, and step into this age of the industry 4.0.
Okay, I liked your babysitter analogy, and I'm guessing just like there's many kinds of babysitters, Werner, are there different kinds of system controllers to look into to use?
Oh God, yes. There are many different types and providers of system controllers. And remember, I'm 36 years in the industry, so I'm going back to, let's say, in the 1980s, we were building very simple styles. We used selector switches, some pressure switches, gauges, and timers. Later on, it moved into PLC-based types with a single pressure sensor with some kind of a control scheme that typically was a cascade control, and then all the way up to nowadays where we have the latest computer-based versions of these controllers. The sophistication goes from manual operation to pressure and timer-based solutions to cascade pressure controls, as I mentioned, and nowadays all the way where we have very sophisticated control algorithms using communication protocols and technologies that are available today, not in the 80s, that also offer remote monitoring or control via the internet or intranet connections. So the range of support for those devices from the homemade PLC or the other software, and then all the way to a complete package solution, either from a compressor manufacturer or also third-party providers. Some of those have superior support for future expansion and the software and operational changes that you will experience. Others have been abandoned. They no longer have any support for both hardware and software. So be buyer beware. Another type that's out there is a networking type where the compressor manufacturer dedicates one compressor to be the master controller along with sometimes proprietary software. So be mindful of what you choose for the long-term growth of your company. A separate controller allows for more flexibility, easier upgrades, and integration of a variety of different compressor types or models or brands.
Tom, as an 80s kid, I've got to get a shout out to Adventures in Babysitting. It really reminds me of that. What are you going to get? Who's going to show up in the driveway? So great analogy there, Werner and Tom. We get some very specific requests from customers. And, not only do they want a master controller to orchestrate what's going on with the compressors, but they also want to handle many other facets of your compressed air system. So if you're in the market for a master controller, make sure that you do your research and find one that's going to work for you today, but can also grow with you tomorrow. And that's really one of the things that I'd like to stress.
Well, Neil, maybe we can ask you to follow up on that. How do system level controls help achieve better efficiency? Maybe that's in part matching your system to the right controller.
Yeah, absolutely. I kind of alluded to this before, and I said it this way, using the wrong machine at the wrong time. But what about using the right machine at the right time? If you've heard me talk about master controllers before, you've heard me say many systems grow over time, and that maybe that's a euphemism for, yeah, we started out with a 20 and now we have a 50 and then we needed a 200, and these things happen, and it's easy to forget or not even know which compressor is best to run at any given time. And in a lot of cases, if you're the maintenance supervisor or you're in charge of the compressors, you just want to make sure that they're on and ready to go, right? Because that's the most important thing. You have to have pressure, which means you have to have flow. But do you know which one should be run at which time? Why not let that master controller choose which is the best compressor for that current demand, because demands change. We see thousands of air audits a year, and a majority of them vary from shift to shift, weekend, weekday, peak, off peak. Some of them are automated and they're pretty much stable all the time. But this load optimization that's available from master controllers nowadays is fantastic. They're going to also reduce idling and runtime. So not only is it going to choose the right units to run when, but it's also going to make sure that they idle out and shut down. And you're going to hear us talk a lot, or if you listen to any other industry leads, about key performance indexes. So we call them KPIs. It's a fun term. For compressed air, one of the big ones is specific power. So kilowatt per 100 CFM. It's just like miles per gallon for your car. And you also have that cost of compressed air, which is dollars per 1,000 CFM. So these are values if I was a production manager or plant manager or owner of a company, these are things that I'd want to know. And a master controller is going to trend these values over time, and then allow you to look and see where your efficiency gains can be made. So not only is a master controller going to strive for the most efficient, it can give the user trend data to confirm that.
These programmable modern system controllers, they have the ability to know the compressor in great detail. As a minimum, the performance at full load, idle, or whatever speed, if it's a variable frequency drive, and at whatever pressure the compressor is operating as directed by this master controller, and then be able to calculate the specific power that Neil mentioned to keep the energy cost at a minimum, but still provide what is needed, but at the lowest energy and maintenance cost. I know I repeat myself. The key is to know when to turn a compressor off that is not needed and selecting the right compressor that is needed at that particular moment in time. I compare this ability very often to a chess computer. It knows each chess piece and their capabilities individually. It looks at the current situation, and then it calculates and chooses the best move forward at every step of the game.
Interesting analogy with chess then too. And for a lot of our primary audience, which is maintenance and reliability folks, asset managers, I think they are playing this constant chess game with not only balancing energy efficiency against reliability, but trying to figure out which are the most critical machines to keep running so that machines that might happen to fail don't take the majority of the production line down. Werner, could you talk a little bit about how multi-unit controls factor into the job of the maintenance and reliability manager and technician?
Sure. I know reliability is always a little bit of a difficult one, but with those master controllers that have network compressors, not just compressors, also dryers and filters, etc., where you can check differential pressure, etc., for the maintenance. They're a single point where you get all the relevant maintenance reminders, as well as alarms or warning messages at a single point. Those messages, they can either be displayed locally and or emailed or messaged to whoever is in charge of that specific message. So different messages go to different people, maintenance versus catastrophic event. Warnings allow time for maintenance scheduling, while the alarms typically require immediate action or planning for a shutdown or repair in the near future. These controllers would also allow for continued messages, but as well send actual performance data, like I mentioned, the delta P on filters, etc., or rising temperatures into the cloud, where there could be a service provider that uses appropriate algorithms to look at the data for that specific component, and then use it to actually prevent such messages to appear, meaning the catastrophic ones, by projecting potential maintenance or even failures for the future. That in my book certainly counts in the reliability department. One more thing about the actual controlling part that can provide. Pressure stability is something I would put under reliability as well. Bring on backup units automatically. That's reliability, no human interaction. Reduce cycling and wear by selecting the right compressors for the ongoing air demand. That would be about maintenance.
Yeah, one thing I'd like to kind of hammer home, and I think we've already talked about it, is maintenance is typically the one thing that we put off, whether it's for the compressed air system or other utilities within the plant, whether it's because of added costs or having to shut the equipment down, which could stop or slow production. That's the biggest thing that we have to worry about inside a facility. Many customers, they choose to run to fail, or they don't choose that, but that's what happens. It's not something we'd suggest, but that's the reality. Having a master controller act like a big brother or a parent, constantly reminding the user what's going on, maybe it's somewhat annoying, but when used appropriately, it can really be a game changer. And so if you plan to do maintenance, you're planning to have a reliable system, and that master controller, it can be the conduit that you need to kind of break through.
Werner, let me take a deeper dive into some of the technology specifics of compressors, specifically variable speed drive compressors. These are becoming a lot more common these days. What would you say are some of the considerations for integrating one or more of these VFD units into a system?
That's a great question, Tom, and then just right down my alley since I love VFD machines. A lot of people have been truly convinced by all that talk over all these years that variable speed, anything, including compressors, is the absolute best. Others, again, are reluctant due to concerns about extra cost, complexity, and questionable reliability in their minds. So the bottom line is that it should be the actual system requirements that should be driving you to the ultimate solution, maybe with or without or even multiple variable speed. So nowadays, those drives are very compact and sophisticated, and they can easily be integrated into systems with a modern master controller by networking, all digital. Gone are the days where we had to have analog to digital converters and high-low handshake signals. Today, all digital and very precise. The system can be completely controlled by one master, and that includes even different size VFDs, not just more than one, but also different size, as long as that controller is fully aware of the capabilities of each of those compressors. So here are two of the main reasons to go with either one or more VFDs. Number one, very stable or consistent system pressure that is mostly required by the application or processes in the plant. And that would mean without any elevated pressure like we use on flow controllers. No, they just want the minimum pressure and done by variable speed. Multiple VFD compressors are used if a rather large compressed air demand range is required. And it varies so much that just one large VFD will either not be able to cover that range, or there's a need for backup compressor, which in some cases is also VFD, so that would make it two smaller machines. We have a number of systems with Kaeser here that are running 3 or even 4 VFD compressors at the time, but the system controller is running only the number that is required to fulfill the current demand. And it also considers the varying efficiency of each one of those compressors over their entire control range. Sometimes we call it also the digital twin, which is rebuilt inside the controller. So one of our recent systems, they have 1000 CFM VFD compressors, whereas the demand can be anywhere from 300 to more than 2200 CFM for not just the blip of a second, but for sustained time periods. So you have to cover them all with actual compressors in the most efficient way. So the master controller must be able to operate just one by itself and regulate that, or 2 or 3 in parallel, and always running them at the optimal specific performance. If they're the same type or the same machine, they would run pretty much at the same speed when in parallel mode. If that is either too high, too much, or in particularly too low, in terms of flow, it will either turn another one on or off, and to get back into the sweet spot of each of those machines. So please consider those applications. Those are rare. Okay. Another scenario that happens sometimes is that you have a VFD trim solution for the high demand production times, and then you have a smaller one for second or third shift, and sometimes even the weekend, where just that small machine is running. You don't want to run a 300 horsepower VFD for a 30 horsepower weekend. So last but not least, please be mindful that VFD compressors have higher running hours, which means service hours that could lead to higher maintenance costs, life cycle costs, in particular if that compressor is oversized. We have a whole webinar just on that topic. Turning a unit off when not needed or outside its best performance is, of course, a major benefit of such a master controller.
Interesting. And sometimes a maintenance manager has to have nerves of steel to make sure you don't oversize, because they want to make sure that you do have that capacity you need to keep the lines going.
Exactly. Yeah, that's a great point, Tom. And I think that dovetails into the point I'd like to make is, if you want to know if your system will benefit from variable frequency driven compressors, is to do an air analysis. And that's going to help you avoid that oversizing. And so if you have flow and pressure data, boom, you can kind of figure out, hey, will my system benefit from a VFD? What size VFD do I need? And another plug for that master controller or system controller, most of these devices out there, they can actually provide you with a data set that you can look at and make that determination. So, really a powerful device.
Well, Neil, you mentioned a couple of key data points, and oftentimes maintenance managers can be awash in various kinds of machine health data, from temperature and pressure up to vibration of rotating machines. When it comes to compressors and these multi-unit control systems, what kind of information do you see these controls providing that's useful to the maintenance and reliability folks?
Yeah, it's a great point. It's a great question. I think you pointed out some of the things that as a manufacturer we would certainly like to see. The big thing is compressor health, right? So are there any alarms? Are there any messages or warnings that's going on with the units? And that would then trigger some kind of action. But in general, like I just mentioned, that continuous supply side audit, great set of information. So you can see, okay, well, I have 1, 2, 3, 5 different units. How are they actually operating? What's that flow profile? These master controllers will also calculate your energy usage. So then you can see how efficient you are. So that key performance index, kilowatt per 100 CFM, trend that over time. The baselining existing conditions is a must. So once a master controller goes in, you can see, okay, where are we at? The interesting thing is most of these you can just flip a switch and turn it back off, and you can really see how the system was performing before. So one of the things that we do with every system that we put in is ensure that when the master controller is off, you can revert back to, let's say, as efficient a system as possible without that master, so that you don't have the same thing that we talked about before, the compressors fighting each other. But in general, it helps to validate any upgrades that you do for management review. So for me, that's pretty key. Many masters out there are going to provide you with a simple table for energy efficiency. So that could be days, weeks, months, or even years. For me as a data nerd, it's pretty great. I just plug in a couple days. How did I do last week? Okay, system's efficient. From a load optimization standpoint, very little idle time. Specific power of the station is pretty good. That cost dollars per 1,000 CFM. That's within a range that we would expect. That data can also provide you with utility incentives if you have to do that, or if your company's ISO 50001, these master controllers should be able to give you that information as well. So there's a lot of data out there. From a system design standpoint and a system efficiency standpoint, you're going to get that. But as you pointed out, temperatures of the equipment, temperatures in the room, those things are pretty important as well. And that trend data, is second to none.
What type of information? In my mind, there's virtually no limit of what can be provided. As long as your system has the sensors or the controls that are connected, and they are able to pump that data to the master controller and or into the cloud for ongoing analysis or for future use, that's it. It's more about what do you really need or even want to know for the purpose of running your business, not just your compressor system, but your business, like how your compressed air usage syncs up with your production and so on. Nowadays, it's about conservation of energy and other resources and running a reliable system to achieve sustainability goals.
Well, maybe we can close on our little higher level question too, Werner. In your opinion, what is the biggest benefit of multi-unit controls from the customer's point of view?
Well, we ask many customers this question. There are the obvious energy cost benefits, remote alarms and messaging, management reports, and other functions. But the most important thing is that people don't want to babysit compressors all day long in order to have a reliable compressed air supply and focus of what they do best, which is their business. Too many people are still forced to physically go to the compressor room to turn machines on or to look up those messages and then see what's going on at the time and then act on that. Having just the one box that turns machines on and off and maintains plant pressure is the biggest benefit to many plant operators. Set it and forget it, and just like a utility, like your power and water, it's just there and no sleepless nights or worries. For the future, there will be more and more sensors, meaning the price is coming down, and then they will be added either within the compressor, dryers, and filters, or even adding to your system additional ones. For example, let's mention compressed air quality sensors. We just went to that conference, and there was a nice display of, for example, simple pressure dew point is basic. That has been around for years, but a total air quality system monitor for compressed applications that justify the cost and provide the required documentation of the proper and reliable compressed air supply, like in electronics, pharmaceutical, food, and beverage applications. The machinery will provide more and more measured data that will be collected and analyzed to predict a future event this is going on. Also, new sensors are being integrated, and they will reduce or eliminate even catastrophic failures that affect your actual business and your bottom line. All of this with just one box, no matter how small or large your business is or your system is.
You know what? Let's face it, we're glued to technology, whether you have, one phone, two phones, whatever it might be. I was joking with Werner. We were both working on the presentation today, the podcast, and, we were watching TV at my house, and the kids were doing their homework, and I was working on this, and, we're watching The Voice. So, perhaps it's a crutch. We're all in the same room. We got to interact. But, think about this. There's a lot of data that you want and you need for your business, and that can be provided from a master controller, pushing it to your office computer or cell phone. You've got a busy day, you've got a lot of things ahead of you. You want to know what's happening in the compressor room, but you don't have the time necessarily to go look at it. You can get reports, you can get alarms. It's a lot of things that you can get. Or like Werner said, this data can be pushed to a third-party service provider. So there's a lot of powerful stuff that's out there, and we're really just scratching the surface of what a master controller can do.
Well, guys, thank you for being here for today's episode. I believe that's a wrap on this year's series. Thank you so much, Werner and Neil.
No, thank you for making us do it. Always a nice challenge.
Tom, it's good to hear your voice. Appreciate everything. And we'll look forward to next year for sure.
That sounds great. And for those who want to hear more episodes from this year, previous topics for the series include alternative design strategies, compressed air system data monitoring, and air as a utility. Those podcasts are archived and available to listen as part of Plant Services Tool Belt podcast, as well as the 2021 series, The Hidden Cost of Compressed Air. So thanks once again to our sponsor, Kaeser Compressors. Thanks to Neil and Werner, and thank you for listening.